So in the last class, I told you NMR. Okay. So we have just started NMR spectroscopy, in which I told you what is the principle of nuclear magnetic resonance spectroscopy and how it works. So I told you we would be applying the magnetic field to the sample. So after providing the magnetic field, so there would be the two possibilities. Whether the proton may align with the provided magnetic field or it may oppose the provided magnetic field. So obviously there would be energy difference, okay, that is delta H. Most of the proton would be aligning with the provided magnetic field so that they become stable, or I can say they would be having a lower energy. Okay. So I can say that before applying magnetic field, all the protons were, you can say, uh, random, just like that. Okay. When I have provided the magnetic field, so they would be aligning in this way, right? They would be aligning in this way. Okay. So I can say that they are having a lower energy right now. Okay. When they have a lower energy, so then I would be providing the radio frequency. Okay. I would be providing the radio frequency. After providing the radio frequency, after providing the radio frequency, then you would see that okay, this proton would flip. Let's suppose this is the proton that would be flipped as a result of radio frequency. So when the proton flip, so they goes to the higher energy. When it goes to the higher energy, and obviously after some time it would be coming back to the ground state. So they would give a signal. So we can detect that signal and we can say, okay, what is this? Okay, this is the proton of methyl, it's the proton of alcohol, it's the proton of carboxylic acid. In this manner, NMR works. Okay. Then I told you the concept of shielded and de-shielded, right? Shielded and de-shielded. Let's suppose this is the proton which is connected to this highly electronegative element, fluorine. So this is highly electronegative element, greater tendency to attract electrons paired towards itself. So this makes proton less shielded. This makes proton less shielded. So then, you know, uh, it can be flipped easily. Okay, because it's less shielded, because highly electronegative elements have attracted electron pair towards itself. Why? What is the reason? Because fluorine is having the highest electronegativity, right? Okay. And then uh, basically there are two types of NMR spectroscopy that we would be studying. Number one is carbon NMR, and the next one is proton NMR. Okay. Also, I told you some elements are NMR inactive, who has even number of proton. Let's suppose you have carbon 12. Carbon 12 is NMR inactive. Carbon 13 is NMR active. Okay. Proton NMR. Proton is active. Why? Because it has odd number of proton. There are three isotopes of hydrogen. The second isotope of hydrogen, that is also known as deuterium, it has two protons. Okay, deuterium, right? So, like, sorry, it has, you can say, uh, in isotopes, the proton remain the same, but the neutrons are different. Okay, but the neutrons are different. So this is an even number, so that's NMR inactive. Okay. Then we have to discuss, as I told you, okay, when we used to discuss relative atomic mass, so we used to say mass of anything compared to carbon 12, mass of anything compared to carbon 12, mass of anything compared to carbon 12. Carbon 12 was the standard. Carbon 12 was the standard, right? So we always relate all the masses with the carbon, okay? Because carbon 12 was the standard. So in this spectroscopy, like you can see the peaks, these are the signals that the sample gave us, okay? And this is the chemical shift, ppm, in terms of ppm, right? ppm means parts per million. It's the lowest unit of concentration, parts per million. So we are going to measure these all the peaks according to this. This is a standard peak, which is the TMS peak. What is TMS? TMS is tetramethyl whose formula is this. If I'm going to draw the structure of this TMS, so you would see this. Central element is silicon, and around the central element you have four CH3s attached. Okay. Then uh, it would give you only one signal. It would give you only one strong signal. Okay, it would give you only one strong signal because it has four carbon atoms. And also, if you can see, it has total 12 protons having the same environment, having the same environment, right? I told you regarding environment, and I have asked some questions related to environment if you remember. Okay, I asked some questions. So its standard peak, that is the TMS peak. TMS is a standard, just like carbon 12. We would be measuring all the peaks as compared to this. Okay, and this peak would be at zero. Okay, uh, it has 12 protons having the same environment, so it would be giving you a strong signal just like that. Okay, only one strong signal because it has only one environment. And then the next thing is that, okay, let's suppose I want to do an MR spectroscopy of any sample. So what should be the state of the sample? It should be liquid, it should be solid, or it should be gas. This is the main thing that you need to know, right? This is the main thing that you need to know. So the thing is that the sample should be the sample should be liquid. The sample should be liquid. Remember, the sample should be liquid. So I'm supposed to dissolve the sample in a particular solvent. Obviously, we have a lot of solvents like water, like alcohol, like hexane, like we have a lot of organic solvents. So the solvent should be the one which is not supposed to interfere in that peak. It's just like कि मैं आपको कहता हूँ कि भाई you need to dissolve sugar in water. So how can you dissolve the sugar in water? Obviously through a spoon. Okay, by the spoon you can dissolve easily. Let's suppose I'm saying that the spoon is made of chocolate, any of the chocolate. So now you can consider, okay, what would happen if you're going to put the spoon made of chocolate into the water just to dissolve the sugar. Obviously, with the sugar, the spoon would dissolve ultimately, if I'm not wrong. Okay, ऐसा ही होगा ना? Sugar के साथ साथ चम्मच भी dissolve हो जाएगी. Then what you would do? What is the job of your spoon? The job of the spoon is to just provide its surface and dissolve the sugar into the water. That's it. Okay. So what is the job of the solvent? The job of the solvent is to just dissolve the is to just dissolve the sample. That's it. It's not supposed to react with the with your sample. भाई मुझे sugar solution बनाना है. How am I supposed to make it? You would say take sugar and just dissolve in water. You know, it's not going to react with water. It's going to dissolve in water. There is a difference between the reaction and the you can say the dissolving of a sugar into the water. There is a difference. लेकिन अगर आपका solvent ऐसा हो कि वो reaction करने लग जाए, so this is not a good thing. The solvent should be inert. The solvent should be unreactive. तो हमें NMR में ऐसा सॉल्वेंट लेना है that should be unreactive, that should be inert. That is CdCl3. That is what? That is CdCl3. So CdCl3 में this is the second isotope of hydrogen which is NMR inactive. So when you are going to dissolve your sample into this solvent, so this solvent would not interfere in the results because it's not going to give any of the signal into the mass into this NMR spectroscopy. As you can see, all the elements are NMR inactive. Okay, so that's why you need to know this. तो मैंने दो चीजें आपको बता दी. Number one, what should be the standard peak, like the standard, and what should be the solvent. You are not supposed to take CHCl3. You are supposed to take CdCl3 rather than CHCl3 because this is proton. Like this is hydrogen. This is hydrogen. It would give you a signal. How can you, you can say, how can you differentiate then? You know, how can you differentiate that this signal is coming from your solvent or this signal is coming from the sample? It would be completely mixed. So to avoid this you are supposed to take such a solvent which should not show any behavior, which should not show any of the response as a result of this. Okay, so that's very important. And then environment की हमने बात की थी. A lot of examples we did. Few of examples are, you can see now, okay, in this only one environment I'm going to see only the proton. I'm going to consider only proton. We have to see the proton environment. तो इसमें कितनी peaks हैं? Now you can see, okay, this and this is the first peak, one peak, second peak. These three hydrogens are the same, the third peak, and this is the fourth peak. Okay, so there are four environments. There are four environments. Remember, okay? There are what? Four environments. Remember. So it's not three, it's four. It's four. It's four, right? So I'm writing that this is having the four environments, proton environments, right? Okay. And then if you can see this, these three hydrogens are same because their neighbor is the same, that is CH2. Always look at the neighbor. It would help you a lot to identify the total number of environments in the sample. Okay, total number of environments in the sample. So these three hydrogens are the same. This is the same. This is the same. And this is different. So 1, 2, 3, 4. Again, the four environments. Again, the four environments. So how many peaks? Four peaks. How many peaks? Four peaks. Okay. And then now you can see, okay, these three hydrogens are the same. It would give you the one environment, and these two hydrogens are the same. The second environment, it's the third hydrogen, which is different. It's the third environment. So you will see only three peaks. Okay, so three environments, so three peaks. And then if you can see, this is the symmetrical compound. It is having symmetry. It is having symmetry. These three hydrogens are the same, and these are the same. So total 6 hydrogens are having the same environments. Why I am saying that the 6 hydrogens are having the same environment? No, क्यों? क्योंकि the neighbor is same. The neighbor is CH2. इसका neighbor भी CH2 और इसका neighbor भी CH2. I'm again saying कि if you are going to look at the environment, so you are supposed to look at the neighbor. You are supposed to look at the neighbor. Remember, neighbor is very important. So the 6 hydrogens are going to give you one peak, and these four hydrogens are the same, it would be giving you another peak. So two environments means the two peaks. Okay, got it? Then you can see it's phenol. It's phenol. OH is connected to the benzene ring. It's phenol. So it's it's the first hydrogen. So it's the first peak. Okay, it's the first peak, and then these two hydrogens are the same. These hydrogens are the same, and this is the same. This is different. So four environments means four peaks. तो इसमें ये और ये सेम है, ये और ये सेम है, ये डिफरेंट है और ये डिफरेंट है. सो टोटल फोर इन्वायरमेंट्स एंड फोर पीक. क्यों पता है? OH के लगने की वजह से. Yesterday I also told you that if you could have only the benzene ring, like there is nothing attached to the benzene ring, all are hydrogens, 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 hydrogen, means in a benzene ring there are six hydrogen atoms. So six hydrogen atoms would be having the same environments. So you would see the six peaks, the six sorry, you would see only one peak, okay, the broad peak of benzene. When we would be discussing the values, regarding the values, the chemical shift in ppm, फिर मैं आपको बताऊंगा कि बेंजीन की जो पीक होती है वो कब आ रही होती है और कहाँ आ रही होती है. ओके, एंड देन इफ यू कैन सी दिस, तो ये वाले जो हाइड्रोजन्स हैं, again you can see the symmetry of the compound. So the six hydrogens are going to give you one peak. Okay, and no, it's not symmetry. क्यों? कि इसके नेबर के साथ जो कार्बन है उसके साथ OH लगा हुआ है, एंड इसके नेबर के साथ जो कार्बन है इट्स नॉट हैविंग OH, इट्स ओनली H. So there is nothing, there is no symmetry in this compound. So if there is no symmetry, so you have to consider each and every proton. If there is symmetry, then you can see what's happening in that compound. But if there is no symmetry, then you have to consider each and every proton. Remember, okay? So, so in this, you can see ये तीन hydrogen same, then second peak, then the third peak, then fourth peak, and these three hydrogens are the same. It would give you the fifth peak. So, how many environments you can see? You would say five environments. If you have five environments, you would see five peaks. Okay, you would see five peaks. Okay, are you getting me? चलें जी. Then after discussing this number of environments, और दूसरा ये कि it's the low resolution NMR. Okay, it's the low resolution NMR. Low resolution NMR पे you can see how we are going to represent different number of environments and the different number of peaks. लेकिन अब now I'm going to zoom it. I'm going to zoom it. I want to see that what the exact structure is, of the sample that we have put into the NMR spectrometer, okay, spectroscopy. So we want to see after doing the low resolution NMR, we came to know that how many different environments are there. तो वी केम टू नो कि भाई इसमें तीन है, इसमें दो है, इसमें वन है, इसमें फोर है, इसमें फाइव है, और एटसेट्रा. बट when you are going to do high resolution NMR spectroscopy, then we are going to discuss in a more efficient manner. After getting this high resolution NMR spectroscopy, so then you would see that एग्जैक्ट स्ट्रक्चर उसका आपको कैसे पता लगेगा. आई वुड टेल यू कि किस तरह से हम इसको यूज करेंगे और क्या इसके एडवांटेजेस हैं. दिस इज वेरी एक्यूरेट. This is very accurate as compared to the low resolution NMR. It's going to give you the more and clear information regarding the sample, regarding the compound that you're going to do NMR spectroscopy. Okay, so before doing high resolution NMR, you need to know कि let's suppose there are two carbon atoms. This is CH3 and this is CH3, this is CH3, this is CH2 and this is CH3. Listen carefully, okay? So I'm asking कि how many environments would be there in a low resolution NMR? You would say two because ye or ye same. It would give you one peak and this is another peak. They are having the same. Okay, it's the low resolution. Now I'm asking about the high resolution NMR. तो अगर मैं आपसे पूछूं कि what about this? You know, it's a proton. It's a proton. So it's अगर ये हाइड्रोजन है तो obviously it has an electron that would be revolving in the out in the shell. Okay, और ये भी प्रोटॉन, ये भी हाइड्रोजन है. Its electron also revolving around the nucleus of an atom. तो जब ये और ये इलेक्ट्रॉन जो इनके हैं वो एक दूसरे को क्या करेंगे, रिपेल करेंगे. ओके, देयर वुड बी अ रिपल्जन इफेक्ट. तो एज अ रिजल्ट ऑफ रिपल्जन, ऑब्वियसली हम हायर रेजोल्यूशन में व्हेन वी आर गोइंग टू डिस्कस द पीक, सो वी ऑलवेज लुक एट द नेबर. So the signal that the proton is going to give you is due to the neighbor around it. So the neighbor would be responsible for the peaks. The neighbor is very important. Remember, the neighbor is very important. Okay. So I'm asking, okay, how many peaks you would see over there, because these 6 hydrogens are the same. तो मैं आपसे पूछूंगा इन 6 हाइड्रोजन्स का नेबर कौन है. आप लोग बोलोगे ये है. नेबर में कितने हाइड्रोजन हैं? आप बोलोगे 2 हैं. So 2 plus 1 that is 3. So 3 peaks. तो 3 peaks. तो इसका यानी कि इसका आपको क्या मिलेगा? ट्रिपलेट. इसका आपको क्या मिलेगा? ट्रिपलेट. ओके, इन दोनों का. बाय द वे, बिफोर डिस्कसिंग दिस आई वांट टू टेल यू कि we would be applying n plus 1 rule where n is equal to the number of neighboring hydrogens. Remember, we would be applying n plus 1 rule where the n is the number of the neighboring hydrogen atoms. Okay, so if n is equal to 0, if n is equal to 0, like there is no any hydrogen that is present in the neighbor of the particular proton or hydrogen, you can say, you know. So I would say ke it would give you only one signet. But if n is equal to 1, so n plus 1 means 1 plus 1, that would be equal to 2. It would give you doublet just like that. And if n is equal to 2, like there are 2 hydrogens, neighboring hydrogen atoms, so n plus 1, 2 plus 1 is 3, it would give you a triplet. Triplet would be just like that. And if the neighboring hydrogens are 3, so 3 plus 1 would be 4. 4 is quartet, just like that. So now you can see it's going to tell you how many hydrogens are present in the neighbor. You know, it's quite accurate. It's quite accurate as compared to the you can say like the low resolution NMR. That's why I'm saying it's going to give you the full flash information. Okay. Okay हो गया जी, चलें. So now the thing is that let's suppose this is the compound, okay, and this is the NMR spectrum of the following compound. Now you can see first of all I want to discuss the low resolution NMR. Okay, first of all I want to discuss the low resolution NMR. So how many peaks would be there? You would say 1, then 2. Okay, and basically if you can see, this is the symmetrical compound. It has symmetry. It has symmetry, right? It has symmetry. Now you can see COOH and COOH, they are the same. COOH and COOH, they are the same. So it would give you the one signal, the first peak, it would give you another peak, it would give you another peak. So the total peaks are three. Listen very carefully. The total peaks are three. Okay, ये low resolution की बात कर रहा हूं मैं. Now I'm coming to the high resolution NMR. Now I'm coming to the high resolution NMR. तो high resolution NMR पे क्या होगा? We would be consider the neighbor. We would be considering the neighbor. Okay. Let's suppose I'm asking this. There is no neighbor of this hydrogen. There is no neighbor. I'm talking about neighbor as hydrogen. अगर आप ये सोच रहे हो कि ये रहा neighbor, ये रहा neighbor, ये रहा neighbor, I'm not considering any of the element except hydrogen. There is no neighbor of this hydrogen. So where n is equal to 0. When n is equal to 0, so n plus 1 rule. That would give you 1. It would give you a singlet. So I'm writing that it would be giving us a singlet. It would be giving us a singlet. Okay. Then what about this? Also, it would be giving us a singlet. Only one singlet because they are the same hydrogen atoms. Then I'm going to consider this. अगर आप इसको देखो तो इसके नेबर में जो कार्बन है उसमें 3 हाइड्रोजन हैं. So neighboring hydrogens are 3. मतलब n is equal to 3. 3 plus 1 4. n plus 1 rule के अकॉर्डिंग देखा जाए तो it would give you quartet. It would give you what? Quartet. Quartet. What about this? इसका जो नेबर है वो एक ही हाइड्रोजन है. बात को गौर से सुनिएगा जरा भाई, ट्रिकी बात है थोड़ी सी. इसका जो नेबर है वो एक हाइड्रोजन है. So it would give you a doublet because n is equal to 1. So 1 plus 1. Doublet. Okay. So now you can match it कि ये जो है सिंगलेट दे रहा है. Now you can see this. Okay. ये आपका क्वार्टेट दे रहा है. Now you can see this. This is a quartet. और ये आपका डबलेट दे रहा है. You can see the doublet. बात समझ रहे हैं आप लोग? You can see the doublet. I'm going to zoom it. It's a doublet. It's quartet. It's singlet. Quartet means just like that. Singlet, doublet means this, 2 lines, and singlet means this. Basically, if you can zoom it, so it's not just like this. It's just like that. And it would be a triplet. Okay. So इस तरह से हम क्या करेंगे, अपने कंपाउंड को फाइंड आउट कर रहे होंगे. So it's very easy. Now you can see the values. Now you can see the values. This OH is this, which is around 12.7, which is around 12.7. How it's having, now you can see it's de-shielded. You know, it's de-shielded because electronegative element is attached to this. And also you can see that its lone pair is delocalized into this. Lone pair is delocalized into this. Okay. So it's de-shielded, right? It's more shielded. 1.1. 3.3 is this hydrogen. Okay. So now you can see, okay, it's going to give us a quartet. Now you're thinking that, कि सर examiner कैसे पूछता है question? Sir, examiner कैसे पूछता है question? Let me give you an example कि how the examiner would be asking related to this. Okay, see this. See this. This is the question related to this. First of all, he is saying कि a sample of benzocane, a sample of benzocane uh, shown below was analyzed by proton NMR and carbon-13 NMR spectroscope. Predict the number of peaks that would be seen in the carbon-13 NMR spectrum. Now you can consider the carbon atoms, not the proton. So 1, 2. So you can see this is 1, this is 2, this is 3, this is 4. ये 5, ये 6 or ये 7. So total 7 peaks you would see over there. Okay, 7 peaks you would see. मार्क कर दूं 1 2 3 4. जो सेम है उनको मैं एक ही कलर से कर रहा हूं 5 5 and then 6 then 7. तो टोटल 7 peaks है. ताकि आपको कलर से पता लग जाए. यू कैन सी कि ये और ये सेम है क्योंकि इन दोनों का नेबर एक ही है. एंड दे आर सेम क्योंकि इन दोनों का नेबर सेम है. सो नेबर मैटर्स अ लॉट. नेबर मैटर्स अ लॉट. तो टोटल काउंट कर लो, आपके पास 7 पीक्स आ रही है. ओके, तो पीक्स मींस द नंबर ऑफ एनवायरनमेंट्स. नंबर ऑफ एनवायरनमेंट्स मींस द नंबर ऑफ पीक्स. ओके, if you are going to find out the total number of environments, so in short you are going to determine the total number of peaks that this sample would be giving you if you are going to put this sample into the NMR spectrometer. Okay, okay, now you can see it's singlet, like it's the TMS peak because it's on 0. Then you have triplet, then you have quartet, then you have singlet, then you have multiplet. It's multiplet, it's singlet, it's quartet, it's triplet, and it's the peak of TMS. So how many total environments are there? And it's the proton NMR. But they are saying it's the proton NMR. Okay, it's not carbon-13 NMR. How many peaks would be there in the low resolution NMR? You will say 4 peaks. Okay, there are 4 peaks if you are going to consider the protons. There are 4 peaks. Okay, 1 2 3 4. सेट हो गया जी. ओके हो गया. Then you can see suggest why CdCl3 and not CHCl3 is used as the solvent when obtaining a proton NMR spectrum. Because CdCl3 may will not show its peak as D is inactive to NMR. It's NMR inactive. Now this is the main question. Use the data booklet and the spectrum in D part 2 to complete the table for the proton NMR spectrum of benzocaine. The actual chemical shifts for the 4 absorptions have been added for you. Okay. So 1.2 पे कौन सा group responsible है? 1.2 पे if you can see, we can see the triplet. 1.2 पे you can see the triplet. You can see the triplet. Before going to do this, let me tell you something which would help you a lot to identify this. I am asking के इसकी क्या peak नजर आएगी? CH3 की. Okay. You will say कि सर इसके पड़ोस में 2 हाइड्रोजन है. So it's 2 plus 1. So it would give you triplet. Listen very carefully. It's so interesting. और इसमें कितनी पीक्स नजर आएंगी? आप बोलेंगे सर इसके पड़ोस में 3 हाइड्रोजन है. So 3 plus 1 is 4. So you will say कि सर इसका हमें नजर आएगा 4 plus 1 और 3 plus 1 4. इसका हमें क्वार्टेट नजर आएगा. Okay. This benzene ring, this whole benzene ring would give you multiplet. Then these two hydrogen atoms would give you a singlet because there is no any neighboring hydrogen atoms. So one triplet, one quartet, and one singlet, and one multiplet. So you can match the following NMR spectrum to this sample. So this compound, it matches 100%. It matches, right? Okay. Then, then now you can see CH3 1.2 would be that, if I'm not wrong. Am I right? तो इस तरह से करोगे तो आपको काफी हेल्प हो जाएगी. So group responsible for this peak, you would write CH3, CH3, CH3. The number of hydrogen atoms responsible for the peak, 3. Splitting pattern triplet, splitting pattern triplet, right? It's so much easy. It's so much easy. Remember, it's so much easy. Okay. Then you can see K. Then they are asking the peak at 3.5. Then they are asking the peak at 3.5. Now you can see that 3.5 per there is a quartet. There is a quartet which is due to this. Which is due to this CH2. Are you getting me? Due to this CH2. बात समझ आ रही है मेरी? तो मैंने लिख दिया CH2. नंबर ऑफ हाइड्रोजन एटम्स रिस्पॉन्सिबल 2 हाइड्रोजन है. स्प्लिटिंग पैटर्न क्वार्टेट आ रहा है. बात समझ रहे हो आप मेरी? देन 5.5 सिंगलेट. सिंगलेट किसका आएगा? सिंगलेट तो NH2 का आ रहा था. मैंने लिख दिया NH2. नंबर ऑफ हाइड्रोजन रिस्पॉन्सिबल 2. पी के सिंगलेट. मल्टीप्लेट इन्होंने पहले से लिखा हुआ है 7.1 से 7 मल्टीप्लेट तो मैंने आपको बता दिया बेंजीन रिंग का आता है. कितने हाइड्रोजन हैं? 4 हैं. So I have written 4 hydrogen atoms are responsible. So this is benzene. इस तरह से आप सॉल्व करोगे भाई. In this way, the examiner would be asking these type of questions. Okay. So just chill karo. Explain the splitting pattern for the absorption at 1.2 ppm. As you know that it's going to give you a triplet. How? Why it's going to give you a triplet? I'm going to apply the n+1 rule. According to that rule, it should have the 2 hydrogen atoms, neighboring hydrogen atoms. If you ask, sir, why? Because it's going to give you a triplet. Triplet means what? It should give you 2 plus 1, that is equal to 3. So 3 means that it would be giving you a triplet. So how the splitting pattern is there? So you would say that K, 2 hydrogen atoms are present in the neighbor. Okay. Due to the 2 hydrogen atoms present in the neighbor, as you can see, okay, it would give you this triplet. Why? Because इसके पड़ोस में CH2 है. CH2 में कितने हाइड्रोजन हैं? 2 हैं. तो 2 + 1 = 3. तो ये जो ट्रिपलेट आ रहा है ये CH3 का आ रहा है. और ये CH3 का ट्रिपलेट क्यों आ रहा है? इसकी वजह से आ रहा है. अगर मैं आपसे पूछूं CH2 के पड़ोस में 3 हाइड्रोजन है तो 3 + 1 4. तो 4 मतलब क्वार्टेट. तो ये जो CH2 का क्वार्टेट आएगा वो इस CH3 की वजह से आएगा. मेरा मूड किस पे डिपेंड कर रहा है? मेरी कंपनी पर. बात समझ रहे हो भाई? आप सुकून से बैठे हो, आपके आसपास में लोग शोर कर रहे हैं, आपको बहुत गुस्सा आ रहा है, तो कंपनी मैटर कर रही है ना. कंपनी ने आपका मूड को स्विंग कर दिया. तो ये जो सिग्नल आएगा इट वुड बी चेंजिंग व्हेन द नेबर चेंजेस. The signal would be changing if the neighbor changes. So it's all about the neighbor. It's all about the neighbor. क्यों we are considering the neighbor? Because वो एक दूसरे को spin pair repulsion की वजह से वो जो है वो it would be giving you a signal. So we have to consider that signal. We have to see that signal basically. So signal को हम फिर further study करके अपने compound को जो है ना उसका एग्जैक्ट फिगर हमारे माइंड में आ जाएगा, एग्जैक्ट स्ट्रक्चर आपके हाथ में आ जाएगा. And then you can go ahead, whatever you want to do. Okay. तो ये है NMR spectroscopy. So we would be doing some other questions as well. A lot of things that we have to do in past papers. तो भाई मैं सबको कह रहा हूँ बेटा, ये आज कम लोग आए तो बेटा next class में inshallah we would be discussing the rest of the questions. Okay, thank you.